Welcome back to the GCSE Maths Pro YouTube channel. In this video, we'll be going through the topic of error intervals. So for error interval questions, they're normally quite obvious because they will mention the words error interval in the question, and often 2 marks. There are 2 different types of error interval questions, kind of categories of error interval questions. Some of them are the exact same concept as upper and lower bounds. If you're higher tier, you will know what that is, in which case, same thing. The other category is slightly different, and we'll look at that at the end as well, and I'll point that out to you. So for example here, we've got a number, x, is rounded to 1 decimal place. The result is 2.7. Write down the error interval for x. So an error interval overall is, an interval is another word for some kind of range. So you're looking for 2 answers. Often they might give you in the answer box the layout of your answer, and you can see that you need 2 numbers. However, sometimes they don't, which is why I've left this one blank. But for error intervals, you need to know it's 2 marks because you need 2 numbers. And the layout of the answer will always be some kind of interval, as in a range. So you need to use inequalities. So in this case, I'm going to use the letter they've given me as part of my answer. And then the lower inequality is always also equal to. The bigger inequality is not equal to. It's just less than whatever this number is. So we need a number here and we need a number here. So when I say it's similar to upper and lower bounds, you kind of need the smallest number and the biggest number, don't you? Because we're saying that x, so the original number before they rounded it to 2.7, the original number should be something between the lowest value that it could possibly be and the highest value it could possibly be. We just need to find out what is the lowest value that it could possibly be and what is the highest value it could possibly be. So that's where it comes down to, is it similar to upper and lower bounds or is it not? Is the concept the same? Is it not? In this case, yes, it's the same. Whenever you've got a number, or it might be a context to it, you'll see some examples in a minute, where it's rounded to anything. In this case, 1 decimal place, 2 decimal places, significant figures, the nearest 10, the nearest kilometre, anything that is rounded, you can tell that it's rounded. That's when you're going to think, oh yeah, and this is particularly for higher tier students, it's the same as upper and lower bounds. If you're a foundation tier student and don't know what we mean by upper and lower bounds, that's fine, don't worry. I will explain to you how to figure it out anyway. So, because the number is 2.7, this is how I kind of like to do it. You don't have to draw any of this. If you feel like you know the answer straight away, absolutely fine, but just as a kind of deeper bit of explanation. I like to draw a little number line. When it's rounded, I'll draw a number line. 2.7 in the middle. The actual number itself was obviously probably longer than 2.7. It had loads of decimals. We don't know what they were exactly, that's fine. We can't guess it exactly, which is why we're trying to find a range of possible answers. If it's rounded to 1 decimal place, what I tend to do is on my number line, do whatever this is, in this case 1 decimal place. 1 decimal place below would be 2.6. 1 decimal place above would be 2.8. Now, those aren't the answers, but it's therefore going to be halfway between those 2. So can you see how that would give me? Halfway between 2.6 and 2.7 is 2.65. Because think about it, if it was 2.65 and they said round it to 1 decimal place, you would round up, wouldn't you? You would round up to 2.7, that's fine. And then this other side, halfway between 2.7 and 2.8 would be 2.75. Now, this is where the difficulty comes in. Because you're probably thinking, yeah, but if it was 2.75, I would technically round up to 2.8, which I know is true, yes. That is why we have these specific inequality symbols. 2.65 would go here. So I'm saying that x, the number, is anything greater than or also could be equal to 2.65 because 2.65 would round up, that's fine. But then no more than the 2.75, so it's not equal to 2.75, is it? Because as we said, that would round up. It's just less than 2.75, so that accounts for, let's say, 2.749. But then if you wrote that down, that would be wrong because technically what about 2.7499? That would also be correct, that would round down, wouldn't it? But what about 2.74999? So the problem is that we could put 9 to infinity, recurring to infinity. And you can't write that on your piece of paper, can you? It's too long. So that's why you do just write the bigger number, but the inequality symbol on the right-hand side is not equal to the bigger number. It's just anything less than that, which would therefore be correct. Okay, so don't overthink it by thinking, oh, but yeah, but there's 9s recurring. That, don't overthink it like that. Just figure out what's smaller, what's bigger, and put those 2 numbers. And if they do make you write the inequality, remember that the lower inequality has to be the equal to 1, and then the upper inequality is not equal to. So effectively, our x number is somewhere here, isn't it? Like it includes this, but it doesn't include the top one. And that in this concept is the same as upper and lower bounds, isn't it? If you said what was the upper and lower bound for 2.7 rounded to one decimal place, you would say those two values, wouldn't you? So it is the same concept. So for those of you that understand upper and lower bounds, it's kind of easy to just overlap it with that. Okay, another example, we've got a number n is rounded to the nearest 10. The result is 130. Write down the error interval for n. Okay, so in this case, because it is rounded, again, it doesn't matter what it's rounded to, as long as it's rounded, the concept is the same as upper and lower bounds, so the same amount above as below, isn't it? You might be able to just figure this out straight away, but if you want to know using my visual method of the number line, that's fine. Put your number in the middle, 130. Now, what is it rounded to? The nearest 10. So do 10 below, 120, and 10 above, 140, and then as I said before, don't forget it's not that, but it is halfway. If you feel like you've got the answer straight away, that's also fine, it's just up to you. So you can see I've got 125, which is halfway, and 135. And again, 125, if you've got 125, and they said round to the nearest 10, you would round up, wouldn't you? So that's fine. Also including 126, 127, you would round all of those up to 130. However, 135, I do understand that you would round it up to 140, which is again why I'm emphasising the fact that this second inequality symbol does not include the equal sign. Because we're not saying that the number n, whatever n represents, we're not saying that it is 135, we're just saying that as long as it's anything less than 135, which as we said before would include 134.9, but also 99999 to infinity, and I can't write that many nines down. So that's why I'm just going to write 135, but it's less than that, it's not equal to that. So anywhere between 125 included up to 135, but not including 135, would be the error interval for n. Okay, so hopefully I've kind of over-explained it here. You could get a question where it's actually got a context. So here we've got the length of a pen is 156 millimeters to the nearest millimeter. Write down the error interval for the length. So you can see to the nearest millimeter, that again, the concept is rounding, isn't it? So it is the exact same as upper and lower bounds. You don't have to draw this as I said, but if you wanted to, because it's rounded to the nearest millimeter, that means 1 millimeter. So 1 below 155, 1 above 157, and then you go halfway. So you can use this method to figure out any version of the rounding. What would be the error interval or the upper and lower bounds? That'd be 155.5 and 156.5. And there's your two answers. Okay, hopefully you've got the gist by now. If you have, pause the video, give this one a go for yourself. So we've got the width of a pool is 25 meters to the nearest meter. Write down the error interval for the width. So upper and lower bounds, you can do kind of a little bit less. So because it's to the nearest meter, half of a meter less would be 24.5. Half a meter above would be 25.5. That's if you didn't want to draw the number line out. You would just put it like that. That's fine. Okay, so now we're on to the other category. So the first category for this question was when they mention that they've rounded it to something, then it is the same concept as upper and lower bounds, half the amount below, half the amount above. There are two scenarios which are in category number 2. The first one is if they use the word truncated or truncate. Now some of you might not know what this is, might not have seen it before. I didn't really know this word in just general life, I'd not really seen it before. Truncated is where, let's say you have loads of digits, they just say they cut it off. They just counted a certain number and cut it off after that. They didn't care what came after it, they just cut it off. So for example, in this case, a number, y, is truncated to 1 digit. So they looked at the first digit and then after that, whatever came after that, they cut it off. The result is 6. Write down the error interval for y. So it's not that it could be like 6,000 or something, but it is the 6 as in the units column. But what we're saying is it was originally 6 point something, something. We don't know how many decimals it had. There were digits here. What they did is they came along and they said, look at the first digit. Okay, the first digit is 6. And then we're going to cut off everything that follows it. So that could mean, we don't know, but that could mean maybe it was 6.0. Maybe, or 0.25, I don't know, I'm making this up. Maybe it was 6.9. We don't know what came after the 6. What we do know, though, is that it 100% started with a 6, because they looked at the 6, they accounted that, they said, yeah, there's a 6 there, that's the digit number 1, and then after that I'm going to cut it off. So it hasn't been rounded up, has it? It's not been, because obviously if you looked at this to 1 decimal place rounded, you would round it to 7. That's not the case. They just looked at it and went, okay, 6, cross out the rest. I don't care what came after it. So if you do see one where it says truncated, it's kind of almost easier if you can remember this. The smallest number is always whatever number they give you. Because as I said, it could have been 6.0. It could have been 6.0, couldn't it? 6. We don't know. We don't know what came after the 6. We know there was definitely a 6 there, 100%, but we don't know what came after the 6. So whatever number they give you, put that as the lowest number. So that's at least 1 mark anyway without even worrying about it. Now, this is where the biggest value gets a bit confusing. Because technically, yeah, the biggest value was 6.999 recurring that it could possibly be. But as I said in the previous one, you're not going to mess around by putting recurring 9s to infinity. There's not enough space. So come back to this concept here of the inequality symbols. It could have been equal to 6 or slightly bigger than 6. Yeah, fine. 6 point something. Up to 6.9 recurring. So up to, the biggest number after that is then 7. Now I know it can't be 7. I know I've said it is definitely 6 point something. But remember that we said here, the inequality symbol on the right hand side is not equal to that, is it? Do you see how that says that y could be 6 or greater, but has to be less than 7. So it kind of is just somewhere 6 point something. So I would just put 7 here. I know it can't be 7, but we've not said that it is 7 because there's not an equal symbol, okay? So hopefully the inequality symbols are making sense here. So just 6 and 7. Now I'll show you another one to give you another example. So a number z is truncated to 3 digits at this time. So they looked at the first 3 digits, then they cut off everything that followed. So the result is 12.4. Write down the error interval for z. So as I said, in this case, if you just see the word truncated, just think, yeah, the smallest value is 12.4, or whatever value they've given you. Because, as I said, it could have been 12.40, couldn't it? We don't know. We don't know what came after the 4. Could have been zeros. So that is the smallest value it could be. Can't be anything less because the person has 100% seen the 12.4, and then after that is what they ignored. Now the biggest it could have been is 12.4 and then 9s, couldn't it? 9 to infinity. But again, we're getting into that scenario where we're not going to write down recurring 9s. So actually the biggest value beyond that is 12.5, isn't it? Because we're including anything slightly less than 12.5, which would have to be 12.4 something, wouldn't it? Because it's not equal to 12.5, it's just anything less than that. So that's my error interval, 12.4, 12.5. Now the final part of that same category, so we're still thinking on the concept of truncation, of truncating, is the wording here. If you see one where it says something about a calculator display, think, okay, this is the exact same as truncating. So it's just got a context basically. So the number on a calculator display began 5.2. ... We don't know what came after the 5.2. Imagine taking your calculator and reading the first 2 values. You've definitely read them, but then you ignored what came after it. Complete the error intervals. As I said, it's the same as truncating, isn't it? You've read the first 2 values and you've ignored anything that came after it. So it could have just been 5.2. So the smallest is the same number as we just said, whatever number's in the question. If it's a concept of truncating, it's just that number is the smallest value for your error interval. Now the biggest it could have been is 5.299999 recurring. In that case, because we're not including the equal symbol in our second inequality, as we've said multiple times, technically it's then 5.3, isn't it? We're saying it's not 5.3, but it's anything slightly less than 5.3, which would therefore have to be 5.2 something. So there's your answer. So that's exactly the same as the previous one with the truncating. It's exactly the same. So you've got 2 categories, one which is rounding, which is basically the same concept as upper and lower bounds. The other category is truncating. Either they will use the word truncate or they will use the concept of looking at a calculator display and only reading the first 2 or 3 digits. That's the same thing. So that is everything you need to know on error intervals. Hopefully that would be an easy 2 marks for you to gain now in your exam. Just remember that there are those 2 different types of error interval questions and which one is it that you've been given. So thanks for watching this video. If you found it helpful, make sure to like and subscribe and leave down below any questions or comments that you might have.